oil and gas industry, correct? Oil and gas industry, correct. So oil and gas industry has two part. Okay, so it has two part. The first part is called as upstream, okay, and the second part is called as downstream. Okay, so this is called as downstream, DOWNSTREM, downstream. Okay, so now let us understand what is upstream and what is downstream. So it's a part of oil and gas only. So basically what is happening here is like you have a sea. Okay, you have a sea, so it's a sea, it's a sea, and below the sea there is a seabed. What is that? Seabed. Okay, so below the sea is called as seabed, correct. So what is happening here is people like, or you can say the scientists or the geologists, whatever you want to say, they go to the sea and they send seismic waves. What they send? Seismic waves to the surface. Okay, now these seismic waves will get reflected back to them, correct. When it get reflected back to them, they will come to know that there is a oil reservoir below the seabed. What is this? Oil reservoir. Okay, oil reservoir below the seabed. Now this oil, or basically I can say crude oil. Okay, not it's oil, it's crude oil. It's crude oil. Understood? So it's a crude oil reservoir below the seabed. Now this crude oil is placed in a form of three elements. So at the bottom you have water, pure water, drinking water you can say. Then at the center you have oil, and at the top you have gas. It is your natural gas, correct. So it is set up in a way like water is at the bottom, oil is at the center, and gas is at the top. So it is arranged as per their density. Water has more density than oil, that's why water is at the bottom, oil is at the top. Natural gas or gas is like lesser density than oil, that is why it is at the top. Okay, till here you understand? Okay, now what is happening here is this box it is called as reservoir. Okay, this reservoir has a boundary. See, this is a boundary of the reservoir, correct. This is the boundary of the reservoir and it is called as sedimentary rocks. Okay, it is called as sedimentary rocks. So now this rocks has a property to hold thing inside it. Okay, and at the top it is called as, this is called as cap rock. What is called? Cap rock. So basically it is a structure of a bottle. A bottle has a body and at the top it has a cap. So it is a bottle which store water, oil and gas, correct. Now what is happening here is when these guys come at the top of the sea, they will bring their FPSO. They will bring their FPSO, floating platform ship offloading, right. So this FPSO will come at the top of this reservoir, and from this FPSO they will send the drilling bit to drill this bottle or drill this reservoir. So this drilling bit is inside the tube umbilical tube. That's a flexible tube which carries that drilling bit. There will be some robotic arrangement which will be set up on top of the cap rock. The drilling bit will go through that and it will do a hole here. Now once they do a hole, what will happen? This height, is more than 15 kilometer, for example, 15 kilometer, it's too much, correct? 15 kilometer is the depth of the sea. So because of this depth, there is a huge pressure on top of this cap rock. And if you put a drilling hole here, what will happen? Everything which is inside this reservoir will try to go upward due to pressure difference. What will happen? This whole thing will become smoothie. You know na, smoothie, milk, banana, and in the mixer you just blend it. So this will become slurry mixture. What? Slurry mixture. Useless mixture, you can say, useless. There is no use of that. So basically this whole process is called as upstream. So it's a part of upstream. Now it is not finished yet. So what will happen when you bring this slurry mixture to the FPSO? So now you have a FPSO here, correct? Now you have a turret here. In this turret you will have a arrangement of something like this. This is your turret, and from the turret you have a drilling bit like goes like this. Now inside turret, outside turret, depends. Okay, I'm not going into detail of that. Okay, so this mixture will come to this turret, and from this turret it is going to the process unit, which is at the top of the FPSO, right? So what is this? Process unit. Process unit. Okay, now this process unit, the function of this process unit is to separate gas, oil and water from that slurry mixture. From that slurry mixture, its work is to separate out oil, gas and water. Now once they separate out oil, gas and water, now your job, now they have a tanks here below the process deck. You have a tanks here. In this tank they will store these oil and gas. They store the oil here and they will store the gas here, right? They have containers inside this, so they can store oil separately and gas separately. Now at the back side of the FPSO they have one more ship is standing there, and they offload everything to that, because you cannot move this FPSO from this, correct na? Yeah, it will always remain here only, right? So if it is like a this well, the now the what you can say, the choice of equipment means, sorry, choice of platform, you can say. Either you can go for a fixed platform, like we have in India, we have Mumbai High. So it's like a fixed platform, permanently fixed there. And if your oil reservoir is very small, so then you will use the FPSO. Otherwise you will go for a fixed platform. Yeah. So if it is a FPSO, because if the oil reservoir is too small, so they use FPSO, and they will store the, they will separate everything here, and they will store respective component in the respective container, and they will transfer it to the respective ship. And this transport ship will take the oil or gas to the refinery. So this whole process is called upstream. Taking crude oil from the seabed, separate the gas and oil from the slurry mixture of or from the oil reservoir, separate it out and send it to the respective area or respective refinery or respective plant. This whole process is called upstream. Understood? Now, yeah, what is, okay, what is hydrocarbon? Okay, so basically crude is equals to hydrocarbon. Okay, crude is called as hydrocarbon. So crude has a chemical value of C122H, sorry, C, okay, capital C22H122. So 22 number of carbon atoms is placing in line, means it is like this. dash C 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 dash like this. Okay, so 22 carbon atoms, and at every bond you have three hydrogen atoms. So one this side, one this side, one this side. So three hydrogen atom here and three hydrogen atom at the last, and at the center two hydrogen atom. So this is called, basically it is, crude oil is called as here, no, not hydrocarbon only, long CH LONG, long chained hydrocarbon. Crude is called as long chain hydrocarbon whose chemical value is C22H122, right? And this long chain hydrocarbon is a useless product, is a useless product. So what you are basically doing here is, you are taking a slurry mixture of this two FPSO, separate out the natural gas and separate out the crude oil, not only oil, otherwise you will get confused, crude oil and water. They will use it for their personal use, and remaining water they will dump into the sea. Okay, they are not going to carry the water with them. Yeah, so these two things they will keep in the FPSO and transport it to the transporter ship, and this ship will take this to the refinery. This is your refinery. Okay, so in the refinery what is happening, the guy who took the oil or gas, whatever the oil or gas you separated in the FPSO, that particular ship will come and park here. So there will be a jetty where your FPSO is going to park. Correct? FPSO means the tanker or the transport ship, vessel. Yeah, it will come here, and from the pipeline, it is going inside the plant where you have your tank farms. What? Tank farms. Tank farms. Okay, so there's a big massive tank farms will be there. They're gonna store these crude oils continuously. They will come, the transport ship will come and they will park here and they will transport the crude oil to these tank farms. It's a massive tank farms, not a small one, massive one, like a size of a stadium. Okay, so those tank farms will store the crude oil. Correct. Now that crude oil still have the impurities. Okay, so what are the impurities usually crude oil has? They have lead, sulfur, correct, and some of the wood particles, correct. So that's the reason they have these tank farms. When they put the crude oil in this tank farm, these heavy particles will settle down. Heavy particles will settle down the below the tank farm, but still the chemical impurities which crude oil has, that is not going to be removed from the crude oil. So what will happen after this? After this tank farm, the crude oil is going to a units. Where? Units. So there will be multiple units, one, then two, then three, similarly 4, 5, 6, so many units will come. Okay, one more thing, the number of units is depend on the number of impurities. If you have a crude which is high in impurity, you need more number of unit to separate those particular impurities. You got my point? Suppose if you have a crude oil, basically the crude oil from the Gulf countries has more impurities than the crude oil from the European countries. That's why you see the European countries refineries is smaller in size as compared to the Gulf refinery. The Gulf refinery are massive in size because lot of impurities to be removed from the crude oil, right? That's the reason. Okay, so from this tank farm, the first and the most important unit, that is your CDU, crude distillation unit. Okay, from this crude distillation unit, what is happening here is, there are two process. One is called as thermal cracking and one is called as steam cracking. Okay, so there are two process of breaking a what? Steam cracking, Second one is called as thermal cracking. So these are the two process of breaking a crude oil into smaller molecules. Okay, so steam cracking means you are injecting a high temperature steam in the crude. So what will happen in chemistry? We learn, like, if you have a molecule and if you burn it, the bonds between the atoms is gonna break. So similarly, this long chain hydrocarbon molecule is useless for me until and unless I break it into small pieces. So have you heard about the distillation column? Like in 10th class we studied about distillation column, right? So in the distillation column, yeah, so in the distillation column we have a burner at the bottom. At every different temperature, you will have a byproduct. Yeah, it's a trays are there in the inside the column, and at every different temperature you will have a byproduct. So at the bottom you will get what? So basically, you know what are the components, like when you break the crude oil. So basically it will be your gas, then petrol, diesel, kerosene, naphtha, asphalt, bitumen, tar, right? The lightest gas will be at the top, and then it will goes down. So gas will be there, then petrol, diesel, kerosene, naphtha, asphalt, bitumen, tar. These are the byproducts from the CDU unit. Now again, the petrol that you generated here in CDU unit is not qualified to put directly in the vehicle to use it. Correct, na? So that's why these byproduct will goes to different units, and at the end they will reach to the tank farms. Okay, yeah, it's a separate tank farm, so it is called as byproduct tank farm. Now this is a generic name I am giving, okay, because if you go to the project, there will be different naming and philosophy will be there, but byproduct tank farm will be there. So they will store all the, there will be a let us assume 3 petrol tanks, 3 diesel tank, 3 kerosene tank, 3 naphtha tank, okay, something like that. So you will have a tank farm again. That's a byproduct tank farm. Now can you use this byproduct directly to the, or can you sell this directly? No. Then we have a blending station. What? Blending station. So like when we drink, suppose for example, if I am drinking whiskey, so what people usually do, and I prefer soda, or maybe someone else prefer water, someone else prefer coke. So everyone has its own standards, you can say. So similarly, to use this petrol in a bike, it has its some standards. Okay, so what we will do here in this blending station is we are adding what? We are adding additives. What we are adding? Additives to enhance the performance of product, to increase the octane number, or to achieve a certain octane number. Have you heard about, like in, like here in my place, like we have petrol in as per their octane number. Okay, they called as E5, E10 and all those things, right? Unleaded, yeah, yeah. Similarly, so what is this blending station do? They will add the additives to enhance the performance of the product or to achieve certain standards. Correct? After this blending station, it will goes to the final product farm. Final product. Now previously it was byproduct. Now it's a final product. Correct? Final product. And from the final product, they will goes to the another area that is called as gantry area. Okay, they will goes to the gantry area. So from this gantry area, they will park their trucks and they will load the oil and they will send it to the stations. Station means like for selling. Correct, na? Now apart, this is the complete process. It's a process. Now what happened with the process? You need different auxiliary items, or different utility items. Like for example, you need steam, so you will have one more unit of steam generation. Now for steam you need cooling tower, so there is one more again unit of a cooling tower. Now whatever the waste gases produced in this whole plant, that will goes to another unit, that is called as flare tower. Understood my point? So there will be auxiliary units, there will be utility units, and whatever the water you are using in the whole plant, oily water, sewer water, waste water, drinking water, clean water, whatever water, everything, for everything we have a ETP plant, effluent treatment plant. Got my point? Then apart from this process unit, you will have a warehouse, you will have a scrap yard, you will have a fire station, you will have admin block, you will have a parking area, you will have a labor area, you will have a what do you say, scrap yard you will have. Then you will have a anything left, parking. Then you will have a laboratory. Then you will have parking for every like admin block you need parking, every canteen you need parking. Those are a hazardous place. So many things will be come under the refinery. So how to arrange these process unit? Now the main thing, the pipe rack, which is connecting the whole plant. You got my point? So this is how the refinery works. So in overall plot plan, you will come to know that where the tank fall will come, where the CDU will come, how we are gonna decide this, how we gonna find the figure it out, what type of land is required, what are the important points to consider before starting the layout or before starting the project. Yeah. So those were the things comes under downstream. Sorry, this is for, yeah, overall plot plan. This is called overall plot plan. Now once you understand, okay, this is overall plot plan. Now let us take CDU unit. So when you make a equipment layout, so equipment layout is made for units. Every unit has its own equipment layout. So inside equipment layout, you are showing the equipment location, which equipment is where and what distance from the reference point. That is called equipment layout. And when you add piping in the equipment layout, it will become piping layout. You got my point? So this is how we gonna study the downstream. Okay. Now what will happen? So we will start with this overall plot plan. Then I will explain you equipment layout. Then I will explain you the piping layout. Now once we finish the piping layout, we will start with the basic. Now what is the basic? So we will start with what is pipe. That's the very basic. So what is pipe, and the way of making pipe, and what you can say, the ends of the pipe, because pipe end is related with the joints. Joints mean butt welding fittings or socket welded fittings or threaded fittings. So everything will comes with the pipe's end, the end part of the pipe. Because when you go to a buyer, he's not gonna give you the bevel end pipe or threaded pipe. Everything you have to make it in the site. You when you purchase it from the market, it's like come with a plain end, right? Yeah. So everything 2 inch and above will goes for bevel end. Bevel end means butt welding. Butt welding means 2 inch and above. So that is how we will study, because this is important when you read your PMS, piping material specification. Okay, so let me finish this. So first will be the pipe and the basic way of manufacturing pipe and the pipe ends. Then we will go with the fittings. Okay, each and every fittings we will discuss. That's a discussion, okay, because you already know everything about. So but still we will discuss about the piping fittings, because when I was discussing, when I used to discuss the PMS now, you should understand the description of the PMS. Because suppose for example, if it is given pipe space B cross B. So what is B cross B? B means bevel end cross bevel end. So both the ends are bevel. Okay, both the ends are bevel. So that you need to understand, because we need to read the documents. You got my point? That is very important, na? Correct. So piping fittings we will discuss. Then from here onwards, okay, after this we will jump into AVEVA E3D. Okay, so I will explain the E3D. Okay, E3D we will open the modules. So we will open the first model module. Okay, then I will explain what are the features of that model module and how to use it. Then I will explain you the hierarchy. Okay, so everything has a hierarchy. If you try to model a equipment, yeah, if you try to model a piping, both having hierarchy. Even though for structural cable everything has hierarchy. Okay, there is a way of creating things. So then we will discuss some commands, because I prefer commands too much instead of going to the manual method. So I will teach you both, but I prefer to use command because it will help you in passing the interviews also. Okay, if you have a knowledge of command now, so you will get people will watch you. Okay, this guy knows at least something, because everyone knows that nowadays nobody knows anything, they just come with a fake experience and all. Correct. So commands is very important. Then we will learn the project. Okay, so when we enter in the project, we have to, means like, I will give you the situation, or I will share with you the PNID and all, and we will discuss in the class how to develop a layout, because developing a layout is not that easy a job, because you need to make sure that you consider each and every aspect of PNID and the client requirement. Then only you can develop a layout, and after fixing the layout you can do the piping. Correct. Because when you develop a layout, you have to consider the spacing of future piping which you didn't did, but you are considering that future piping. Okay, this piping it will be from here like this, so at least I have to keep this much of space between the two equipments. You understand my point? Because otherwise you just put like, if you go to any standards now, they will give you the minimum requirement. Okay, there will be a minimum distance between two pump is 1 meter. Okay, but if the pump size increases, that 1 meter will become zero. You got my point? If in the document it says that's from the center of the pump to the another pump center, it should be 1 meter. But if the pump size is increases, that 1 meter will become zero. So actually it has to be from the edge of the foundation to the edge of the another pump foundation. There should be a clear gap of 1 meter. So it is irrespective of the size of the pump. Yeah. And then we know that, okay, we have two pumps in our project, so the back side of the pump has to be always empty. Correct, because for the maintenance of the pump motor, you have to bring the trolley at the back of the pump, and you have to take out the motor and put it on the trolley, and then you have to leave. So you cannot do any piping behind the pump. So that's how layout is fixing. Suppose if you have a heat exchanger, so in front of the heat exchanger you can do piping, but at the back side of the heat exchanger you can't do piping, because tube bundle removable area is there, right? Tube bundle heat exchanger has a shell, and tube heat exchanger has a tube. So you have to clean it. So to clean it, you have to remove all the tubes from that, and it will take the length of the tube plus 1.5 meter clear space you have to keep it. So if you have any equipment which required maintenance, so you have to keep all those equipment near to the road. So it has to be opposite to the pipe rack. So there are a lot of concept, basically I'm trying to say. So do a project when you do a project, you will come to know each and everything. But when you, like you asked me about the syllabus, if I say syllabus, so syllabus is only this: what is piping, what are the piping fittings. Okay, that is the syllabus. But you are not supposed to learn a syllabus, you have to learn how to do a project. Because when you go in a real time, people will give you a PNID, they will give you MDS, and even though you should know these document name first to ask someone. Okay, someone say that, okay, brother, you have to do this area, and your PNID is on this server. Take a printout or whatever soft copy you want, you take it from there and start start piping. So if someone say like that, how you are gonna start it? You understand my point? So their syllabus doesn't work. Correct. There you have to understand. Okay, my first job is to, what is the thing? To read a PNID. Okay, this is my area. So this is my area PNID. Okay, from this area PNID I have to start. So you have to first identify where to start, from which equipment to start, from which pipe to start. You got my point? So the most difficult thing in a routing is to identify from where to start. You got my point? Then to start, how many documents are required? How many documents are required? I need PMS, I need MDS, I need PNID, I need hookup drawing, I need layout. Why layout is needed? To see where are the laydown areas, where are the walkways, right? You have to understand those, and then you need a project design basis to check what are the client requirement. You got a point? So keeping all those things in front of you, then only you can start a project. So that's why I am teaching project only. Okay, whatever comes in the project, we will learn everything. Understood now? Good, good, good. So this is all about what we are gonna do it. Right? Any doubt? No? Expansion loop. Okay, see, basically, expansion loop is a part of piping stress. Okay, so one more thing I will tell you. See, there are two type of lines. One is called as stress critical lines, and another one is called as non-critical line. Okay. Okay, so non-critical lines basically are those lines which doesn't fall under stress critical line. Now the question is, what is stress critical line then? So any line which has high temperature pressure, okay, high temperature pressure, and any line connected to a equipment which has vibrations like pump, compressor, heater, okay, and all the line above 6 inch, all the line above 6 inch considered as stress critical line. In some project, the client says no, I want to consider all the line above 4 inch to be stress critical. See, stress, this 4 inch 6 inch is totally depend on the client requirement. If client want to save money, he will say do only stress analysis for 6 inch and above, because the number of pipe increases, it will increase the cost of the project. Correct na? So totally depends on the client requirement. Now suppose for example, if you have a cryogenic fluid, okay, cryogenic fluid is there and it is going through a 4 inch line, so definitely it will be a stress critical, without a doubt. So any critical line, basically these are the parameters. So if those fall under this, it will consider as stress critical line. And non-stress critical line means anything after the stress critical line is non-stress critical line. Basically 2 inch and below lines are considered as non-critical lines. Okay, then regarding the loops, okay, regarding the loops, so whenever we are dealing with the stress critical lines, the stress engineer will do the analysis of that on a Caesar software, and he will provide the location of loop. Either it can be expansion loop, either it can be 2D loop, or either it can be 3D loop. Generally your flare lines has 2D and 3D loops. Sometimes they can use expansion loops in another different stress critical line, maybe in your compressor area, or not in compressor, sorry, PSV outlet and all those things. There you can use it. Okay, usually okay, 2D loop and 3D loop is nothing but this. 2D loop is a flat loop. 2D loop is a flat loop. 3D loop is a 3D loop. It will goes up and then and go like this. See, basically these loops are provided to withstand the expansion. When the number of elbow increases, it can easily withstand the expansion, thermal expansion. Okay, 2D loop is used when you don't have many lines along with these lines. So generally, suppose for your flare line, suppose this is one line and it has a 2D loop. So you cannot run any other line here because it will clash. Yeah, but in 3D loop, there is no such possibility because it is going up and then go this direction, right? So generally when we use 2D loop, we will keep this at the corner. At the corner means suppose this is your pipe rack. So you will keep the 2D loop line at the corner. Yes, at the last here. You got my point? So that if your line is coming outside, there will be no problem like this. And then you will give us support here at this cantilever or some arrangement you will make it. You got my point? So regarding the loops, it will be given by the stress engineer. Loops or expansion loop, because I never seen any expansion loop used, because for that now you need a permission from the client. Because if you are using it expansion loop. Offshore we can use it. Yeah, correct. Hmm. Yeah, definitely we can use the loop. Water line. Oh, sea water system. Okay. Okay, I understood this. Any doubt? Cool. Okay, so